to express the first bit in partial fractions. And so that will equal, the first bit will be over 1 plus 2x. And then I've got 1 minus x all squared, and so I have to split that up into 1 minus x and 1 minus x all squared. And that'll be a plus b plus c. And actually it's identically equal for every single value. Times by the bottom bit over here will give me 2 plus x squared. Is identically equal to a times 1 minus x squared plus b, and this bit, the 1 minus x will cancel out with one of those, so it'll be 1 plus 2x times by 1 minus x, and finally plus c times 1 plus 2x. Now, because it's identically equal, I can try various values. Obviously I can try x is 1, so when x equals 1, that says that 3 equals, that bit will be 0, that bit will be 0, so it'll be just c times 1 plus 2x's, that'll be 3. Therefore c equals 1. When x equals, if I now get rid of this one here, if I make c be xb minus a half, that will disappear. Actually, so will that disappear. And so negative a half squared is a quarter, so 2 1/4 or 9 over 4 equals, and this will be a times 1 minus a half will be 3 over 2, square it, that'll be times 9 over 4, and that'll be nothing, and that'll be nothing, so that implies that a equals 1. And then I can try any other value. So how I will do it, I'll put x equals 0 because it's dead easy, and that says that 2 equals a plus, what would this be, b times 1 times 1 is 1 plus b plus c, and a is 1 and c is 1, so b is 0. So now I need to put it straight into my integral. So I'll put down I equals the integral of between 0 and a quarter, 2 plus x squared. It's exactly the same thing. So we just worked out that a is 1, so it'll be 1 over 1 plus 2x. And I could do it all in one go, but actually I'm going to split it up into 2 bits, because then I can do different things with different bits depending whether I've got luns, and it looks like I have luns, and it looks like I have numbers as well. Well, lun is a number, obviously. Over, this is the c is 1 over 1 minus x squared dx, and that's good. And first thing here, I can see that if I differentiate the bottom bit here, I get 2. So if I made this one 2, I'd have to have a half outside it, and so that bit there would be a half of ln, the bottom bit, 1 plus 2x, and I do that between the limits between 0 and a quarter, and this one here plus, well, this one here, if I differentiate, it's got nothing like that, so this one here I'm going to change this one to being, that is the same as 1 minus x to the minus 2 is the same as 1 over 1 minus x squared. And so that means I can now integrate this. It's going to be, well, that minus sign is not a minus sign, it's an arrow. So that's what it is. So it's going to have to increase the power because we're integrating. So that'd be 1 minus x. For minus 2, increase it, goes to minus 1. And then it's just trying to see what happens if I differentiate this. Minus 1 comes down the front, times by this to the minus 2, that's good, but I have to times by the derivative of this, which is minus, and minus times minus is positive, so it does give me that. As simple as that. It's just that. And that is between 0 and a quarter. And then we put the various things in. So this will be a half. That'll be 1 plus a half, which is 3 over 2, so that's ln 3 over 2. and minus ln 1, 0, plus, and put in these ones, put in a quarter, so that'll be 3 quarters to the power of minus 1. Let's do it, 3 quarters to the power of minus 1, minus 1 to the power of minus 1. And that's ln 1 is 0, so that equals half ln of 3 over 2 plus, that'll be 4 over 3, and that'll be minus 1, which equals a half ln 3 over 2 and plus 1/3, as they wanted it to be. And that's question 9 done.